So just a brief one to describe how I've been running UFOLBM on the dicehub platform. So normally I would log into dicehub, the staging area, and I've got some open phone caserun demos. Hold on, it's not that one. No, it's actually in UFO GPU testing. So I've got quite a few here, and I think these caserun examples were set up specifically for my use because it doesn't include the standard open foam package. It's just for doing a caserun of a particular executable. And so, for example, this one, the motorbike one here, I'll log into that one. And when it's loaded, yeah, literally just these three files needed. So I've got the STL file, that's the binary STL file. And I've got the executable file, and I've got the text input file. And the executable file has been compiled with the certain options. Let's see what. Yeah, it's been compiled with like this one. So it's using Portland Group Fortran, which is the NVIDIA one, static. So that includes all the whatever libraries are needed. Some other options. And you have ACC for using Open ACC. And then you specify GPU equals CC all. So in theory, this particular one should work for all NVIDIA GPUs that are supported currently. So same program, I can compile it with ACC host, which is just a standard serial version. So that's nothing special. That's just NVIDIA Fortran running in serial. And then there's ACC multi-core. So that's a bit like OpenMP. So that is going to use multi-core or multi-processors on your laptop. So that's quite a bit faster. If you've got 4 or 8 processors on your laptop, you can run it on CPU with multi-core. And then there's the GPU one, which I can't actually run on my laptop because I don't have a suitable GPU. But this is the one that I compile for dicehub. And so previously I had to specify which CC I wanted for a particular GPU. Then I realized that I can do CC all, which compiles it for all GPUs. So that executable is for GPUs only. So that's the one that I upload onto the platform. So that's my executable, that's the STL, that's the input file. And then in this one, the only significant part really is that you have to CD into the data directory, wherever that is. And then you can change the executable, give it executable status, because that seems to get lost somehow. And then I normally run it with the time command so that I know how long it's taken. That's really useful for comparisons. And then when I run it, change machines, so you've got CPU and GPU here. So I just select which one I need. And at the moment, I've just been selecting whichever one, depending on the amount of RAM that I need. So if it's a small case, I can run it on this one. But if it's a bit larger, this one. And if it's larger still, that one. But on dicehub, I generally probably use this one because it's got 20 gigabytes, which is enough for doing like 32 million cells or something. And so having selected that, then press run, and it runs. and when it runs, the output is not really that interesting or useful, to be honest, but it just gives you an indication when it's iterating of how fast it's going. So if you've run it on a CPU before, and then when you run it on GPU, you'll notice that it is substantially faster, like maybe 100 times faster or something like that. Then when it's run, it tells you the maximum velocity in the domain. So these numbers along here are not particularly useful, but it tells you the Vmax and tells you that what output files it's written, and then it also tells you how long it's taken. So this run has taken 126 minutes or 2 hours. So if you can go all the way up to the top, or you can't on this one, but when it runs, it will tell you how large the mesh is when it starts. So that gives you some indication. And then when it's finished running, obviously you can download results if you want. Generally, I would go to S3 access, and then I just go to this one and copy that. So then on my version of Linux, I'll create a separate directory called results, and then I just cut and paste this into the results, and then it copies everything, like all the VTK files, into that directory. And there might be 100 or so VTK files or VTK slices, in which case it takes a while because it will copy all of those into your results directory. And then when you've got a stack of VTK files, then you can read it into ParaView. So that is a fairly quick overview of how I use the caserun feature for UFOLBM.